All right, today we're going to talk about something really, really cool. We're moving way beyond AI that just, recognizes cats in photos or writes poetry. We are diving deep into how we can actually teach an AI to understand the fundamental rules that run our entire universe, the laws of physics.
So that's the big question, right? How do you actually get a computer, a neural network, to genuinely obey the laws of physics? It sounds kind of like science fiction, but the answer is surprisingly elegant, and we're going to break it all down.
See, here's the thing about a standard AI model. It's an incredible mimic. You can feed it millions of data points, and it gets shockingly good at spotting patterns. But, and this is a huge but, it doesn't understand the why behind any of it. It's like a student who memorizes the answer key for a test, but has no idea how to actually solve the problems. A great mimic, for sure, but a truly terrible physicist.
And that brings us to this really brilliant new approach. On one hand, you have your standard networks. They learn from data and only data. They often need mountains of it just to essentially memorize the right answers. But on the other hand, we have something called a physics-informed neural network, or a PIN, and this is a whole different beast. It learns from data, yeah, but also from the laws of physics themselves. This means it can work with way less data, and it starts to actually understand the rules of the game.
So how in the world do we make that leap, from just memorizing things to actually understanding them? Well, the secret isn't some brand new, super complex AI brain. It's actually much more clever than that. The entire trick is hidden in how we grade the AI's performance, in a little something called the loss function.
Okay, so with a normal AI, its grade, what we call its data loss, is really simple. It just measures how far off its prediction is from the actual truth, the real data. Its only goal is to make that error as small as possible. It's only graded on one thing, how well it matches the answers it's already seen.
But with a PIN, this is where the magic happens. We completely change the report card. The AI is still graded on matching the data. Sure, that's the data loss. But now we add this second, absolutely crucial part, a physics loss. It's like we're telling the AI, okay, you've got a whole new subject to worry about now.
What we're really doing is giving the AI a much stricter set of instructions. We're telling it, look, it's not good enough anymore to just match the few data points I've given you. I also need you to follow the underlying rules of the system. And those rules are written as a differential equation, which is just the language physics uses to describe how things change. And you have to follow that rule everywhere, even in all the places where you have no data at all.
So what exactly is this physics loss? Well, just think of it as a penalty, a big one. If the AI proposes a solution where, say, energy is just created out of thin air, that violates the law of conservation of energy. The physics loss goes through the roof, and the model gets a terrible grade. It's being penalized for not showing its work correctly, and that forces it to go back and find an answer that's actually, physically possible.
Now, this all sounds great in theory, but you might be thinking, hold on a minute. The laws of physics are written in the language of calculus, right? Full of really complex derivatives. So how can a computer possibly juggle all of that complicated math on the fly?
Exactly. I mean, can you imagine if scientists had to sit down and manually code all the calculus for every single problem? It would be an absolute nightmare. The whole approach would be totally impractical for any real-world use. But luckily, there is a very powerful shortcut.
It turns out modern AI frameworks have a secret weapon, and it's called AutoGrad. You can basically think of it as a perfect instant calculus engine that's built right into the code. It handles all of that messy, complicated math for us, and it does it flawlessly and automatically. This one tool is pretty much what makes the entire idea of PINs possible.
So, let's walk through how this whole loop actually works. Step 1. The AI network proposes a solution. It takes a guess. Step 2. AutoGrad instantly calculates the derivative of that guess. Step 3. We plug that result into our physics equation to see how much it's wrong by. We call this error the residual. And finally, Step 4. That residual becomes the physics loss, that penalty that forces the AI to go back and try again with a better, more physically realistic guess. It's just this beautiful, self-correcting cycle.
Okay, so we've covered the how. We've gotten into the nuts and bolts. But now for the really important part. So what? Why does this actually matter? Why are fields like geology and engineering getting so excited about this? What can it do outside of a computer lab?
Well, this matters so much because in a ton of scientific fields, getting data is incredibly expensive and difficult. Just take geology, for example. You can't just scan the entire Earth's crust. You might only have data from a few drill holes scattered miles apart. That's where PINs are an absolute game changer. They can take that super sparse data And by using the laws of physics as a guide, they can fill in all the blanks and create a complete, realistic model of what's happening miles beneath our feet.
So this is really the key idea to take away. Pins aren't just connecting the dots between the data points we have, they're using the fundamental laws of the universe as a roadmap to intelligently fill in the huge, massive gaps where we have absolutely no data at all. They're learning from both our limited measurements and from the universal rules of how the world actually works.
And that just leaves us with this huge, final question to ponder. We've started by teaching AI the laws of physics. But what's next? What other fundamental rules of our world could we teach it? The rules of economics, of biology, maybe even the rules of social dynamics? An AI that doesn't just mimic data, but that actually understands the rules of the game. Well, that's a profound shift, and it opens up a truly new frontier for what's possible.